briefly these three experiments. The Michelson-Gale experiment used sealed tubes covering a large area that measured the speed of the ether relative to the surface of the Earth. They obtained a value that was within 2% of the known speed of about 0.45 kilometers per second at the equator.
So let me break this down because this is more important than people are considering, okay? Now the Sagnac experiment proved good enough for me, the existence of the ether, but you could argue, I don't know what you could argue, but by spinning the light sources, okay, then you could say that would be the reference frame, would be the not spinning, just a stationary whatever ground, okay? But this Michelson-Gale experiment was an interferometer type of test, okay? It's just splitting the light beams, okay? It's not moving. It's not spinning like a ring laser, okay? So there has to be a reference frame, and it detected 15 degree per hour rotation at the equator, okay? But it did not detect the motion around the sun. So you want to have, if you want for something just sitting there to be able to detect one motion but not the other. So what is the reference frame? There has to be a reference frame, and that's the ether. Okay, they say, that Bob proved 15 degree per hour rotation. Well, what is the reference frame? Okay, so you could, like I said, if the device is spinning in there, and then you could use just stationary itself as a reference frame, but that's not the case with the Michelson-Gale or the Michelson-Morley, and they both detected ether, so it gets better.
But this speed could have been due either to the Earth spinning in a stationary ether or the passing of the rotating ether around a stationary Earth. It was Airy's failure experiment that proved it was the moving ether passing across a stationary Earth. If the Earth was stationary and the stars were stationary, the starlight would come straight into the telescope. However...
So let's get that straight right off the bat. Okay, when we look at stars, we have to tilt the telescope a little bit off center to see it, okay? It's the same with every star pretty much. I even had to do that when I was filming a SpaceX rocket. I had to tilt it off center a little bit. For whatever reason, that's not in contention here. The fact is that we do. So the stars are all coming in, the light's coming in at a certain angle. So if it's farther away, then it must be moving faster, okay? They're all rotating together, but they are coming in at a certain angle, okay? So you can't say that it's the stars moving or the Earth moving just because you have to tilt the telescope, okay? You can't, but you can be certain that one of them is certainly in motion, okay?
If the telescope is moving at, say, 5 miles an hour, you would then have to tip the telescope, let us say, 5 degrees to see the star. However, if the starlight is being carried across the surface of a stationary telescope at 5 miles an hour, you would still have to tip the telescope at 5 degrees to see it. So you cannot tell which one is stationary. To see...
So yeah, basically you could move the telescope, okay, and argue and have to get a little more of an angle change, okay? But you could not pinpoint that to the Earth moving or the stars moving, because you could just say that the Earth's moving more, you're moving more on the ground, so you had to tilt it different. So he come up with a brilliant idea to put the water in there, and they say that the drag of the atmosphere pretty much is why you have to tilt the telescope to begin with. So by adding water, you're adding more drag, okay? So if it's the stars, if it's the telescope, if it's the Earth that's moving, that means the telescope's moving. So think about it. If the Earth's moving, that's basically saying the telescope's moving. And if the stars are moving, that means the telescope's stationary, the Earth is stationary.
Whether it is the telescope or the stars that are moving, all you have to do is to fill the telescope with water, which greatly slows down the light when it is in the telescope. If it is the telescope that is moving, then you have to tip the telescope a little further because of the slower speed of the light in the telescope. However, if it is the stars that are moving past the stationary telescope, then the telescope does not have to be tipped any further because the starlight is coming in at the correct angle anyway. That Airy failed to find any further tipping was needed proved that it was the telescope and therefore the Earth that was stationary. This important conclusion was not even mentioned in his report. It was too explosive.
That's fishy right on its face that he didn't report that. That's fishy right on its face, people.
Is the sun static in space?
Relative to what? The center of the Milky Way galaxy?
Is it static?
The sun is static in our solar system.
No, it isn't.
Yeah, if you're keeping it. Okay, so it's not confined to our solar system.
No. I asked, is the sun static?
Relative to what?
So not static.
What?
Not static.
What? Relative to what?
Relative to. Do you understand what the word static means, don't you? It means
do you
not
know what
moving.
the word relative means?
Yes, I do.
Okay, then why don't you answer the question? Relative to what?
No.
Relative to what?
No. Static means not moving.
Relative to what?
What the fuck? Relative to what?
It was too explosive. Sagnac split a beam of light and sent the two beams in opposite directions around a path, recombined the beams and noted their interference fringes. The whole system was on a turntable, and he then turned it at 2 revolutions per second, remeasured the fringes and found that they had changed. This was due to the movement of the mirrors, made the path for one beam longer and the other shorter. This proved that the ether existed, because once the light left the source, its speed was controlled by the comparatively stationary ether in the laboratory.
Now I'll give the argument that okay, with this, then I could see where you come up with an out if the table is moving, like if the ring laser gyro or the if it's spinning, okay, that's a little bit different, okay, but because you'd have a reference frame that you could argue, but with the Michelson-Gale setup, okay, and the Michelson-Morley, there is no reference frame, okay? That's the whole point. The whole point in the damn experiments to see if there is an absolute reference frame or not, okay? And the Michelson-Morley got a no result for motion, okay? So you want to do away with the absolute reference frame, but yet they detected a certain amount of ether drag, saying pretty much denoting that there is a reference frame, an absolute reference frame, the ether, okay? Now, they want to, okay, so you want to say that there's a, you just chalk that up to error, basically, and say, we didn't get the right amount of ether drag. We only got a certain percentage of that, and even though the equipment was 10 times the sensitivity it needed to detect the Earth's motion around the sun, okay? But you want to claim that that same instrument is detecting a 15 degree per hour Earth turn? No. You can't have that too, okay? It's not like that thing's spinning, okay? That thing is, so that's why I played the reference frame, okay? So if the thing is not in motion and only the light is in motion, it has to be measured in reference to something, Okay, if it's detecting 15 degrees, then in reference to what? So that to me is solid proof that there's an ether or absolute reference frame.
This demolished Einstein's relativity theory, which had abolished the ether. So